In this video, we're going to talk about how to solve a polynomial equation by factoring. And the methods that we're going to use in this section are pretty much identical to the methods that we used back in Chapter 4 when we talked about solving quadratic equations by factoring. The only difference between this section and the one back in Chapter 4 is that now we're not limited to only looking at quadratic equations. We can look at any polynomial equation that we can factor. So let's do some examples. Let's say we start off with this equation, x cubed equals 8x minus 2x squared. The first thing we're going to want to do is we're going to move all the terms onto one side of the equation so that the other side is set equal to 0. So that means I'm going to subtract 8x and add 2x squared to both sides. And just so that our polynomial expression is written in standard form, I'm going to make sure that I'm writing all of the terms in order of decreasing degree. So here's the polynomial equation that we now want to solve. And again, notice that the right side of the equation is equal to 0, which is what we want, so that when we do end up factoring this expression, we'll be able to use the zero product property to solve for our variable. So the next thing we want to do is factor out the greatest common factor from all three of our terms, which in this case is x. So I pull an x out, and then what's left over from each term is x squared plus 2x minus 8. Now we want to see if we can factor that trinomial, and fortunately we can. We want to look and see if there are factors of negative 8 that we can add to get positive 2, and of course those factors are positive 4 and a negative 2. So now we have our polynomial expression completely factored into three factors, which means we have three solutions. To get those solutions, we use the zero product property, and we set each of our factors equal to 0. So the first solution is pretty obvious. We just set that x equal to 0, and that's solved. X equals 0 is our first solution. Then we set the factor x plus 4 equal to 0 and solve for x, so x equals negative 4 is another solution. And finally, we set x minus 2 equal to 0, solve for x, and x equals positive 2. So down here, I'll just scribble in our solution set, which is negative 4, 0, and positive 2. So this polynomial equation has three solutions. Remember back to one of the videos you should have watched last night about the zeros, roots, and x-intercepts. What this means, now that we've solved our polynomial equation, is not just that we have these three solutions. Oh, sorry. Sorry about that. Our neighbor's dog invaded the backyard and freaked my dog out. But I think we're okay now. So anyway, like I was saying, we've got these three solutions to our polynomial equation. And that also means that if we graphed our polynomial x cubed plus 2x squared minus 8x, we would see three zeros, or three x-intercepts, at the location x equals negative 4, x equals 0, and x equals 2. So keep in mind that the solutions to your polynomial equation are also the same thing as the x-intercepts to that polynomial function. Let's do one more example. So here we have the equation x to the 5th plus 4x cubed equals 5x to the 4th minus 2x cubed. Again, our first step is to get all of our terms collected on one side of the equation so that the other side of the equation is set equal to 0. And just like I did before, I'm going to write each of the terms in order of descending degree. So I'm going to have x to the 5th minus 5x to the 4th plus 4x cubed plus 2x cubed. And I'll set that equal to 0. Now, hopefully you notice that we have some like terms that we can simplify. So that we can combine that 4x cubed and that 2x cubed. So our next step will be to do that. And we've got x to the 5th minus 5x to the 4th plus 6x cubed. So now we have our polynomial equation simplified and set one side of the equation equal to 0. Next, just like we did on the last slide, we want to factor out the greatest common factor from all three terms which in this case is actually going to be x cubed. When we factor out an x cubed, we'll have x squared minus 5x plus 6 left over. And that'll be equal to 0. Now we want to see if we can factor out, factor our trinomial into two binomials. So we need to say, are there any factors of positive 6 that we can combine to get a negative 5? And in this case there are. And we can factor it into x minus 2 and x minus 3. So just like we did last time, we're going to have, oops, that should be x cubed. Typo. So just like we did last time, we can set each of our factors equal to 0 to find our three different solutions. We'll set x cubed equal to 0, but of course that'll just mean that x equals 0. We can set x minus 2 equal to 0, so another solution will be x equals positive 2. And our third solution, when we set x minus 3 equal to 0, will be x equals positive 3. Just to tie in one more idea from the video about multiple zeros, if you look at the degree for each of these factors, x, of course, has a degree 3 because it's x cubed. The factor x minus 2 has degree 1 since there's no exponent, and x minus 3 has degree 1. So this means that since each of our three different factors has an odd multiplicity, that the graph of our polynomial function is going to cross the x-axis at those three zeros. And also, if you look at the overall degree of our polynomial equation, it's a fifth degree. I guess this is our simplified version here. It's a fifth degree polynomial with a positive leading coefficient. So I don't have a whole lot of room. I guess I'll move to the next slide. Let's go ahead and create a rough sketch of what our polynomial function is going to look like. We said we have zeros at 0, 2, and 3. So I'll go ahead and say here's 1, 2, 3. And I'll plot those three zeros. So one's here, and we said it was at 2 and 3. Because we have an odd degree polynomial function and we have a positive leading coefficient, we know that the overall shape of our polynomial function is going to look something like what I just drew up in the left corner of the slide. It's going to begin low and end high. So that means if I'm just trying to draw, and again, this is just going to be a really rough sketch, I know that I'm going to start out somewhere around here. I'm going to pass through, or pass across the x-axis at each of these zeros. So that means my overall polynomial equation is going to look, or polynomial function will be graphed something like that.